In this video here, we're going to be looking at some story problems that will take a look into using and applying systems of equations, specifically for 2x2s. And so we have to create two equations using two variables. So we do need to declare some variables and make two equations to help us solve for those missing variables. Let's go ahead and try out an example here. This story says one day Philip purchased 5 loaves of bread and 3 muffins for a total of $8. A few days later, the same store purchased 2 loaves of bread and 6 muffins for a total of $5.60. What is the single loaf of bread? What is the price of a single loaf of bread and a single muffin? So first off, I always look to see what exactly am I solving for. So I want to know what is the price of a single loaf of bread and a single muffin. So I'm going to make those my variables. Now I'll just go ahead and use x's and y's. I'm just going to be pretty boring here and just call them x's and y's. You can call them whatever letters you want. You can do B for bread, M for muffin, but I'm just going to keep it pretty chill here. So I've declared my variable, so I'm going to say that x that I'm going to be using is going to represent the price of bread and y is the price of muffin. They're variables because I don't know what they are yet, but I will find out soon. So let's get into constructing our two equations. So I want to make two equations that represents the system, my 2x2 system, because I have two variables. So I need two equations to solve for my two variables. I hope it's starting to click now. But in this case here, what we need to do is look back and see what Philip did. So Phil purchased 5 loaves of bread. That seems important. He purchased 5 loaves of bread and 3 muffins on the first day that add up to a total of $8. So in my mind, I'm like thinking, okay, if you're going through a cash register, you're checking out, it's going to be 5 times 5 bread, so 5 times the price of bread, so 5 times X, added with 3 muffins, so 3 times the price of muffins, so 3 times Y. And if I add the total amount of cost of bread and the total cost of muffins, well, then I get $8. So that's equivalent to just writing 8. And so I can do this type of construction with the second equation. And so in this case, the second day he goes, or the next day that he goes to the store, he purchased 2 loaves of bread and 6 muffins with a total of $5.60. So in this route, we have 2 times X, 2 times the cost of my bread added with 6 muffins, so 6 times Y. And so total cost of bread, total cost of muffin added together got me $5.60. Those muffins are real cheap because that was a lot cheaper than my first trip. So when I'm looking at this problem here, I'm thinking, okay, now that I have two equations, I can solve this. This looks like an elimination problem because it's in standard form. The x's and y's line up so nicely. So I'm going to go ahead and use elimination for this case. All right, so when I use elimination, I have to think about which variable I want to cancel. And so I notice that none of them are opposite in signs. And, well, here's my x's. I have 5 and 2, and I have 6 and 3. So it's much easier to change this here to 6 because 3 can be 6 if I multiply by 2, but I need a negative 2. So I'm going to multiply in a negative 2. So my goal is to cancel out the y's in this case. So I'm going to go ahead and multiply in the negative 2, so that's negative 10x minus 6y equals negative 16. So just a recall, whenever you're multiplying a number to change it, you got to multiply everything inside. So that's why all of this is changed down below. And then the second equation just gets brought down. I did nothing to it, so I just copy and paste. So once I add the two equations, lucky for me, the y's cancel because they're opposite sign and same coefficient, so they cancel. And so negative 10 plus 2x gives me 8x, negative 8x. And then that equal sign comes down because the y's cancel. 16, negative 16 plus 5.60 is going to be, let me get my handy dandy calculator. It is going to be negative 10.40 or negative 10.4. So from here, I can go ahead and try to divide by negative 8 to try to get that x by itself. So if I take negative 10.4 divided by negative 8, I get positive 1.3 as my x. So I have my x. Great. Now I need to do is try to get my y value. So if you have your x, you can find y by easily just plugging into either of these equations. So I'll just go ahead and plug into the first equation. It doesn't really matter. So if I go ahead and plug it into the first equation, I'll do it right here. My first equation is 5x. I know what x is. It's 1.3 plus 3y equals 8. So if I multiply 5 times 1.3, I get 6.5. Bring down the 3y and move that 6.5 over to try to get the y by itself. So the goal here is to get that y by itself. So 3y comes down. 8 minus 6.5 gives me 1.5. So if I divide by 3, my y is now by itself. So 1.5 divided by 3 is 0.5. Now, I'm not sure what these numbers represent yet until I look at what I declared my variables as. So my x here is the price of bread. So what I just now know is that the bread price is equal to 1.3 or $1.30. I now know that the muffin price is my y variable, and my y variable says 0.5, or in this case, you can think of that as 50 cents or 0.5. And so now I've kind of written it out in a way that it's more realistic to the real world. And that's it. All right, let's try another one here. So this one's example 2. Again, if you read through the story, you need to figure out what variables are you trying to solve. So it says, a sale on a winter clothing. Cody bought 2 pairs of gloves, 4 hats for $43. Tori bought 2 pairs of gloves and 2 hats for $30. What is the prices of gloves and hats? So this is very similar to the last problem here. So we're looking for the price of gloves and hats. So that is going to be my variables. And again, I'm just going to use x's and y's here. So my x could be the price, or I'll just say glove price, and then the hat price. So from here, I need, since I'm solving for 2 variables, I need 2 equations to help me solve for the 2 variables. So the first equation here says, well, I can represent it using Cody. So Cody bought 2 pairs of gloves and 4 hats for $43. So this would be 2 pairs of gloves that I'll call X plus 4 hats, which is Y, equals $43. So essentially what I'm doing is taking the quantity and multiplying it by the price. So 2 times the price of the gloves, which I don't know what the price is, added with 4 times the price of hats. And then when you add them together, you should get the total cost of checkout, which was $43. And we'll do this for Tori as well. So Tori bought 2 gloves as well, and she bought 2 hats. So a little less shopping for Tori. So 2 times X plus 2 times Y gives you $30 that Tori spent. So we're going to go ahead and try to use elimination because, again, this is in standard form. In fact, for most story problems, you want to use elimination. It just becomes very easy to build an equation using standard form versus, y-intercept form or slope-intercept form. So back to this problem here. If I want to try to cancel out a variable, I can see that none of them are on opposite signs of each other. But I do notice that the x's are already the same coefficient. So I'm going to go ahead and maybe make the bottom multiplied by -1. So if I take -1 and multiply it to the bottom, I can make this a -2 so I can cancel out with the +2 that's on top. So that's kind of my game right now. So the top equation, just copy and paste because I did nothing to it. So easy peasy. Then the second equation, got to distribute that negative 1. So that's negative 2x, negative 2y equals negative 30. And here I go to add up my equation. So if I add up my equation, well, that cancels because they're opposite signs, same coefficient. Whereas the 4 and the negative 2 add to give you positive 2y, and 43 minus 30 is, well, 13. So if I divide by positive 2, if I divide by positive 2, y is equal to, well, 13 divided by 2, that has to be 6.5. So that is my y value. Now I have to think about getting my x value here. So I get to pick whichever equation I want to use. I'll just use the second equation just to be different. So going with the y value that I have, I'll use the second equation. So that's going to be 2x, which I don't know what it is, 2y, my y is 6.5, equals 30. So working this out, this would be 2x plus 2 times 6.5 is 13 equals 30. So if I try to subtract the 13 off, this would cancel, 2x comes down. 30 minus 13 is 17. If I divide by 2, x is equal to 17 divided by 2, which is 8.5. All right, so I have my y, I have my x's. Let's go ahead and summarize what we just found. So it looks like the price of gloves is going to be our x, which is $8.50. So I'm going to write here, glove price is $8.50, whereas my hat price is my y value, which is 6.5 or $6.50. And that's it. All right, so let's try out some of the practice problems just so that we make sure we understand how to do the story problems. So I'm deciding to do the practice problems with you guys. This is a freebie bonus point, so take advantage of it, guys. All right, so for this problem here in question 2, it's asking you to do the same thing, read through the story problem, and use elimination or using systems of equation to solve for the variables. So this one says, Harvey has some $1 bills and some $5 bills. And in all, he has 6 bills worth $22. How many of each type of bills does Harvey have? Now, I think it would be fun if you just pause this video for a sec and try to guess how many $1 bills and $5 bills he has, given that his total amount is 22. I think you could figure it out without systems of equation. But in this case, I'll show you how to do it using systems of equation and how it's applicable. All right, so first off, got to declare my variables. We want to know how many of each type of bill that Harvey has. So that means that we want to know, like for X, the number of $1 bills that are present, and for Y, the number of $5 bills. So we're not looking for price anymore. We're looking for quantity, essentially, because I know how much a $1 is. It's just $1. So in this case here, we need to build our two equations. So when I'm looking at the story, I can see, like, in this case, there are 6 bills here total. So I'm thinking, well, if I just take the number of $1 bills I have and the number of $5 bills I had, I know they add up to be 6 bills. So I can say that when I add X and Y, because they represent the quantity, they should equal 6. So I can start off there. And then I can also deal with something with the price here, the 22. So what I know is that if I knew how many number of $1 bills I have, I can just multiply $1 with X, right? Because this is the number of $1 I have times 1, the price of a $1 bill, then I can figure out the total amount of money I have with $1 bills. For Y's here, I can do the same thing for $5 bills. I can take $5 and multiply it by the number of $5 bills I have. And when I add them all together, I should get $22. So that is my system of equation that I can use. So looking at this, I noticed that the x's have the same variables. This is already a 1x technically, but in this case, I want this to be a negative x, so that way they can multiply, that they can be a negative x, so to cancel out with this bottom. So I'm going to multiply in with a negative 1 to force it to be a negative x, 1x. So if I were to do that, my first equation would end up being negative x negative y equals negative 6, and then the bottom would just stay the same. So it's just 1x plus 5y equals 22. So if I add, then the x's cancel, and this is negative 1 plus 5, which ends up being 4y equals 6, negative 6 plus 22, which is 16. So if I take 4 and I divide, y is equal to 16 divided by 4, which is 4. So I've already figured out what y is. I can go back and solve for x. So I can plug it back into the first equation, which might be easier since the first equation is so simple. It's just x plus y equals 6. So if I plug in my y, which is 4, that means, well, if I try to get x by itself, x needs to be 2. So it turns out in this problem here, the number of $1 bills I have, number of $1 bills is 2. I have 2 $1 bills because it represents my x value, so I have 2. And the number of $5 bills represents my y value, so if we look at our y value here, it is 4. And that's how you can use system of equation to help you solve for this problem. All right, for the last one here, it talks about dimes and quarter. Victoria has been saving dimes and quarters. She has 94 coins in all, and the total value of coins is $19.30. How many dimes and how many quarters does she have? So this problem is very similar to the last one, only we have to deal with coins. So in this case, let's take a look here at declaring our x and y's. So from the story, you can see that they want you to find the number or the quantity of how many quarters and dimes she has. So very similar to the last problem, we want to find the number of dimes and the number of quarters. In that case, we need to start with making two equations so we can solve for the two variables. So the first equation could just be adding the number of dimes and the number of quarters, because we know that if she adds up her dimes and quarters, the total amount of coins she has is 94 coins. So we can say that that's equal to 94 if we add up x's and y's. We know that the total value that she has in coins is $19.30. So this tells me, well, we can always multiply how much a dime is relevant in cost. So a dime is 10 cents, which in decimal form is 0.10. And we can multiply by the quantity of dimes, which is x. I don't know how many quantity of dimes we have, so we use a variable. And then for y, which is the quantity of quarters, quarters are 25 cents or 0.5. And I can multiply that by y. If I add them together, the total number, or how much I have in dimes and how much I have in quarters, I should get $19.30. So from here, I can try to solve. And this one's a little tricky because I'm dealing with decimals. So again, I have to think about which variables I want to cancel. Perhaps it's the x, since I just could try to make them both 0.10. And I can make this one a negative, so I can multiply the first one by negative 0.10 just to try to make it cancel. And this is totally fine. You can have decimal numbers or coefficients. So if I multiply negative 0.10 into the first equation, I get negative 0.10x and negative 0.10y. If I take negative 0.10 and multiply it with 94, I get negative 0.94. And the bottom equation, I did nothing to it, so I'm just going to bring it down the way it is. So if I add this equation, the x's cancel. If I take negative 0.10 and add it with 25 or 0.25, I get 0.15 y. And if I take negative 9.4 and add it with 19.3, this would give me 9.9. So if I take my decimal to divide with, to try to cancel this side, I need to divide it on the other side as well. So y is equal to 9.9 divided by 0.15, which actually ends up being a nice number. It ends up being 66. So I found my y. I just have to go ahead and find my x. So I'm going to use the first equation because it's just x plus y equals 94. Or if you think about it, an easier way to just solve this problem is just take 94 of the coins and subtract 66. Or we can just do it the traditional way. So if I take x plus y equals 94, my x here, I don't know what it is, but my y is 66. So if I take 66 and subtract it off, my x here is 94 minus 66, which is 28. All right, so that means that for this problem, the number of dimes I have is, let's see, our dimes are x value, so 28 dimes. And then the number of quarters I have is 66 because it represents my y value. And that is it, guys. That's it for this video. I hope this helped with understanding how to do story problems and how to set that up. All right, until next time, guys. Bye.